Hello, welcome back. In this session, we will be looking at ccBPM. We've touched upon ccBPM when we looked at the components of PI. So now we will be going ahead and doing a deep dive on ccBPM and how ccBPMs are used in a dual stack environment. Just a recap, ccBPM stands for Cross-Component Business Process Management. ccBPMs are available only on a dual stack installation of PI. A dual stack installation of PI is a PI installation that contains both a ABAP stack and a Java stack. The reason ccBPMs are available only on dual stack installations of PI is because ccBPMs run on the business process engine, which in turn runs on the ABAP stack. Okay, so with that, why do we need a ccBPM, right? So far, all the interfaces that we've been building are what we call as point-to-point interface, right? What we mean by a point-to-point interface is there's a sending system that sends the data and there's a receiving system that is receiving the data. There is only two systems involved, and between those two systems, you're doing a data transformation and so on. What if you wanted to do a much more complex process? What if you were dealing with a scenario where a sending system sends a file to PI. PI makes a RFC call to SAP. Let's say a sending system sends a file that contains a user ID. PI is supposed to make a call to BAPI user get detail, the RFC, get all the fields that are part of the BAPI response and push it back to a file, right? In this case, what you will realize is the sending file system is asynchronous, whereas the receiving system is synchronous, right? So in such scenarios, how do you build this scenario, right? You would typically end up using a ccBPM because you're going to build a bridge where one sending system is asynchronous, whereas the receiving system is synchronous, and so on. Before we go into this scenario that we will be looking at, a RFC file scenario, let's look at the various step types of a ccBPM, right? A ccBPM is once we build a ccBPM, you will understand it a little bit better more. But let's say ccBPM is nothing but building a business process in PI, right? BPM stands for business process management. So your ability to build a complex business process in PI in the integration layer is what is the usage of ccBPM. So what are the step types of a ccBPM, right? The first step type we will be looking at is, there are two categories, messaging relevant and process relevant. We will look at the messaging relevant step types. The first step type is a receive step type. So this is what a receive looks like. This is the icon for a receive. A receive step type, as the name implies, is used to receive a message. So anything that deals with messages are messaging relevant step types. So for a ccBPM to receive a message, you use a receive step type. For a ccBPM to send a message, you use a send step type, right? The send step can be both synchronous and asynchronous. If you're sending a synchronous call, you make a synchronous step type, as the send step type as synchronous, whereas if you want to make it an asynchronous call, then you just will also select the type as asynchronous. Okay, so receive step type is used to receive a message in ccBPM. So whenever you want a ccBPM to receive a message, you will use a receive step type. Very important point, any ccBPM will always start with a receive step because PI is dealing with messages. Your ccBPM always has to start with a receive step. A receive step is typically the first step of your ccBPM. Okay, so receive steps are used to receive a message and trigger a business process, and ccBPMs typically will start with a receive step. A send step is used to send a message out of your ccBPM to a third-party system. Send steps can be both synchronous and asynchronous. A synchronous send step means ccBPM is going to make a synchronous call and get a response back. The step will wait for a response before it goes to the next step. A transformation step is used to execute a mapping. So the mapping that we've been building so far, the graphical mapping and the Java mappings and the XSLT mappings that we have built so far, all of them can be used within the transformation step. So if you select the transformation step, one message format is going to get converted into another message format. So that is the use of a transformation step. A receiver determination step is, as the name implies, to identify who are the receivers for this message. Okay, so if you are getting a message and you want to dynamically identify for this message who's the corresponding recipient, then you use a step type that is called receiver determination. Okay, process flow relevant messages. These are all messages that are more with regards to the process flow. A container operation, right? What is the container operation? A container operation is a step type that enables you to act upon the messages. So any message that you receive within your ccBPM is persisted within a container or a variable, right? Now, if you want to perform an operation on that container object, then you use a container operation. We will look at that as an example. Control step is used to control the processing of your flow. There are different types of control steps: exception handling, monitoring, alerts, deadlines, and so on. Okay. Then you can always have a loop. So if you want a sequence of steps to execute within a loop, then you use a while loop. You can have fork. If you want multiple branches for execution in parallel, then you use a fork. Okay. So loop, as the name implies, is used for looping. Fork is when you want parallel executions, where you want multiple branches to execute in parallel, then you use a fork step. Block is nothing but a sequence of steps, right? So you can have a receive step, a send step, all of them a sequence of steps combined into one particular set of steps is called a block. Okay, wait step is for ccBPM to wait for X minutes or X seconds. Switch step is nothing but a switch or case. If you understand the concept of switch case, then a switch case is nothing but a switch step is nothing but to enable you to identify the path of your processing depending upon switch case. Okay, let's do a quick another look at this. A receive step receives a message into your ccBPM. Whatever message is received is typically persisted within what we call as a container element, right? The message is received from the integration engine into the business process engine. The receive step is typically the first step of your ccBPM and triggers your ccBPM, right? Send step is to send a message from your ccBPM. A send step, when a send step is used, the send step will trigger the message from the business process engine to the integration engine. A send step can be of two types: asynchronous and synchronous. A transformation step is used to perform a mapping operation where you want to execute a mapping. All different types of mappings are supported. A 1:1, a 1:n, a n:1, and an n:m mapping are supported. Okay. Receiver determination, as we mentioned, is used to perform an operation to identify the list of receivers for a particular message. Container operation. Remember, all the messages that so far receive, send, and transform, they deal with messages, and these messages are persisted within what we call as containers. In ccBPM language, it is called containers. In other words, it is also called as a variable, right? But in ccBPM language, we will be using containers. So these steps, whatever message they are dealing with, they get persisted within a container. So a container operation is your ability to act upon that container and add a message, append a message, delete a message, and so on. Okay. Control step is used to perform actions like deadline monitoring. If you want to make sure that a BPM executes within 1 hour or 10 minutes or 5 minutes, and if it does not, then you trigger an exception. Stuff like that is done using deadline monitoring. Exception handling, what happens if an exception occurs? How do you handle that exception? If you're from a Java background, exception handling is like a try catch block, right? Alerts are nothing but your ability to trigger an alert to a business user or to any technical user to say something is wrong, or basically send a message out. While loop, as the name implies, there is a while loop, and that while a loop will have a deadline or an end condition. A fork is used for parallel processing or for branching of your messages. Wait step defines a wait time before which the next step will be executed. A block step is equivalent to a for loop. A block step is basically, if you want to execute a for loop, then you can use a block step. A for loop without any condition, a block step without any condition will execute the sequence of steps one time. A switch case is for determining outcome. It's like a programming language. When you write a switch case statement, that's when you use a switch step type. Okay, there's been a lot of theory in this. Do not worry. After this, we're going to do hands-on, and that will give you a better feel of how a ccBPM works. Now, before we go about building a ccBPM, I want to describe the scenario that we are building and also help you understand how the scenario, what are all the objects that we will be building in the ESR, and what is the flow going to be like in the integration directory. Okay, first of all, what is the flow that we are going to build, right? You're going to get a sending system is going to send a file to PI. PI is then going to make an RFC call. So the file is going to contain one input field that has the username. The requirement is you get a file with one username, you make a RFC call to SAP, you get the RFC response, and then you push that response back to a file, right? So you're going to get a file in PI. Now, once you get the file in PI, you make the RFC call in SAP into SAP. Once you make the RFC, so you get a file. This file will now be delivered to your PI and BPM, and then the BPM will make an RFC call, and that will get out as a response file. Okay. Now, from a PI perspective, how does this go, right? So from a PI perspective, the way you need to look at is BPM is nothing but another sending system or a receiving system, right? So for the RFC file scenario that we are looking at, you will have a center file adapter that will be using an outbound asynchronous service interface, right? File adapters are always asynchronous, so you will be using an outbound asynchronous service interface, and the center file adapter will pick up the file. Now it will come to PI, and PI needs to send the message to someone, right? Now the recipient of this message is going to be your BPM. So the receiver is BPM, and now for the BPM, you will notice that we are using, so far we've always called our service interface SIOA or SIIA. O stands for outbound and I stands for inbound. There is a third type called abstract, right? So for ccBPMs, all the service interfaces will always be of type abstract. This is a rule of the thumb that you need to remember. ccBPMs always deal with abstract service interface. ccBPM always require abstract service interface. So anytime you build an interface where ccBPM is a sending system or the receiving system, make sure that your service interface is of type abstract, right? So in the first flow, the center file adapter picks up the file, and our service interface outbound asynchronous is associated with the sender file adapter. And now PI will now send the file to a BPM, right? So BPM becomes a receiving system, and the inbound interface that is used there is going to be SIAA of type abstract asynchronous, right? So now the BPM has received the message. Next, the BPM now needs to have a mapping. So the BPM will have a mapping that where the request is mapped to the BAPI response, and after the request is mapped to the BAPI response, the BPM is now going to send the message out, right? So now, again, remember BPMs always deal with abstract interfaces. So again, your BPM will have, in the next case where BPM is sending the request to the SAP system, your BPM will become the sending system, ECC will become the receiving system. Your sending interface is going to be abstract synchronous because BPM is going to make a synchronous call, right? So your service interface is going to be an abstract synchronous service interface, and the inbound interface is going to be the BAPI that uses the RFC. So now the synchronous call is done, BPM gets the response. Now the BPM needs to send the response back to a file, right? So now what the BPM is going to do, it's going to use again an abstract. See, everywhere with the BPM, all the interfaces are always abstract. And now A here stands for asynchronous because you're going to push the request out of BPM to a file system. So if you look at it from an end-to-end flow perspective, there are three distinct flows that you will be executing. Okay. Always remember, from an integration directory perspective or from a PI configuration perspective, a BPM is nothing but a sending system or a receiving system. And then you will have a multiple logic that you will build within the BPM. All right, with this, let's get started. Let's go ahead into the interface enterprise service repository and start our development. Okay, so I'm first creating a namespace. File RFC file. Okay, I'll call it /ccBPM /file RFC file _00. Okay. Okay. Now that is done, let's look at what are the object types that we are going to be building, right? So first thing that we will be doing is you will be importing the BAPI user get details. In our case, we have already imported within our software component, but if you have not, you will go ahead and import your BAPI user get details RFC from the SAP system. You will be creating two data types, DT file request and DT file response. Then you will be creating two message type, one for file request and one for file response, right? How many service interfaces are we going to build? Let's count it here. 1, 2, 3, 4, right? The BAPI is and 5. 5 service interface has to be built. So you will have SIOA, SIAA, and here I missed one, SIIA file underscore response. Okay. So you will build a data type, we'll build two message types for the two data types, and then we'll build 5 service interface. So let's get started. Okay. So I'm here in my file RFC file namespace. I'm going to create interface objects and say data type. And I'm going to call it DT file request underscore 00. Okay. Let's put one element, insert sub element, user ID. I'll call it XSDE types string. Okay. Next, I'm going to create one more namespace, one more data type, DT underscore file response underscore 00, and here let's create insert sub element, first name. We've seen that there are user IDs where the first name does not exist, so we'll call it like that, first name, insert element, last name, we've seen that the first last name is always there, and let's just put one more field that says let's just look at the BAPI and just build one more couple of fields from there. So BAPI user, we are going to use BAPI user get detail. So I'm opening the BAPI user get detail. I'm going to response structure. Okay, personal number, title, first name, last name, middle name. Let's put the title, personal number and title. Okay, all right. So we'll say personal number and we know that the middle name is not being used in SAP, but that's okay. So now the occurrence has to be 0s to 1 because these are not mandatory fields in SAP, and otherwise you will have an error in PI where the message is going to fail. All right, so my data type is created. Now the next step is to create message type. Every time you create a data type, just go ahead and blindly create a message type as well, because without a message type you cannot necessarily use a data type anywhere in PI. Okay, you create a message type. I'm going to drag and drop. The message type is of empty file rec 00. Okay, my message type is created. I'm going to again new, the name of the message type is empty file resp underscore 00. My message type is also being for response is also created. Okay, excellent. Now close all. Let's go ahead and create a service interface, right? SIOA, we'll call it file request underscore 00, right? And it's outbound asynchronous and the message type is this guy. Excellent. Next, we'll call the next service interface SIIA underscore. Is it going to be SIIA? Let's look at the PPT. Outbound asynchronous, and here it's going to be abstract asynchronous, right? So we'll call it AA file rec underscore okay, let's just call it SIAA file request, right? We are receiving the request within BPM. So we are going to change the category as abstract. This continues to be remain asynchronous, and I will say empty file request because your request message is being received within the BPM, right? Now what happens after the request message is done? You need to now make a map this message to a BAPI request, right? But before we do that, what we are going to do is we are going to create whatever is the username. So let's go ahead, SI. The next service interface is going to be SIAS. So BPM is going to make a synchronous call to the BAPI, right? So it's going to be SI abstract synchronous BAPI underscore BPM. Okay, let's call it SIAA abstract synchronous BAPI underscore user underscore get underscore details underscore 00, right? And this is going to be outbound, and this is going to be a synchronous, right? Is it going to be outbound? Sorry, it's going to be abstract. So abstract synchronous. My request is empty file request. My response is empty file response. Okay. Next, this is now going to go into the BAPI, so no worries there. And finally, you're going to have SIAA, right? So let's map that. Again, as always, something wrong with my right click. Okay, excellent. So interface objects, service interface, SIAA file response underscore 00. Okay. It's going to be AA, so abstract, asynchronous, and the message type is my response message type. Okay. Last service interface that we create, SIIA file response underscore 00. This is going to be inbound, and this is going to be asynchronous, and then here I'm going to select my message type and drag him and paste him here. Okay, so with that we are done. We have 5 service interfaces: outbound asynchronous, inbound asynchronous, abstract asynchronous, abstract synchronous, and abstract asynchronous. Okay, so let's go ahead first, before we do anything else, let's go ahead and activate our changes. Okay, so now let's do a recap, right? Let's understand what we've done, right? So you have file. This file structure goes into the BPM, and now the same file structure comes out of the BPM and goes to ECC. So where is the mapping being done for the BAPI structure, right? We have so far not done any mapping. So basically you need to do 2 mappings, right? From the file request to the BAPI request, and to BAPI response to the file response. 2 mappings need to be built. So I'm going to close all. Now I'm going to go ahead and create my 2 new mappings, right? So I'm going to go into my mapping objects and say underscore file request underscore to underscore BAPI underscore request underscore 00. All right. So let it get created. Let the object get created. Now I'm going to select my message type. My source message type is my file request, and my target message type is my BAPI user get details request message. Select the request message. Yes, I've done that. And now my user ID is going to get mapped to the username. And with that, my mapping is done. It's a very straightforward mapping. All right. Next, I have to map my BAPI response. I'm creating a new mapping that says BAPI response to underscore file underscore response. All right. Now I'm going to go ahead. My BAPI user get detail is my request. I'm selecting him, and I'm selecting response. All right. And then I'm going to message type file response and selecting the file response. So now let's go ahead and do the mapping. Personal number will go to personal number. First name will go to first name. Last name will go to last name. And middle name will go to middle name. All right. So my response mapping is also done. Okay. So we built 2 mappings. One from the file request to the BAPI request, and one from the BAPI response to the file response. Now we'll go ahead and create operation mapping. So the operation mapping is OM underscore file to BPM underscore to underscore BAPI underscore sync. Right? It's a synchronous interface. So here my source service interface way. So the BAPI, this is the place where the mapping needs to happen. So you're going to have outbound synchronous. So I'm going to select SIAS BAPI user get detail because that's my abstract synchronous. And then I'm going to select my BAPI user get detail as my target service interface. Let me select this again. Oops. Something is wrong with the way this is much better. All right. So I've done read operations, and now when I do read operations, you will see the request and the response structures displayed here because this is a synchronous interface, right? So now from file request to the BAPI user get detail, I will be selecting my first mapping. I go to the response tab. It's going to say, hey, what is the mapping from the BAPI response to the file response? I'll select, and I'll select my response mapping. All right. With this, my mappings are also done. And now the next step is I'm going to activate my changes. And now this next step is to build your ccBPM. So let's activate the changes. The changes are getting activated. Perfect. So before we go and build the ccBPM, let's just summarize so far what we've done, because it's very important that you understand this concept fundamentally. We are building a file, RFC file, using a ccBPM scenario. There's a sender file adapter that is going to pick up the file. PI's expectation is you make a BAPI, the business's expectation is whatever is the request user that you get in the file, you make a BAPI call, you get a response, you manipulate the response and pull out 4 fields from the response and push it to the target file, right? So now the way we are going to build this interface is to use a ccBPM. So from a ccBPM perspective, you'll be looking at 3 distinct scenarios that need to be built, right? Your file gets picked up by a sender file adapter. It comes into PI, and now PI is going to deliver that file or the request message to BPM, right? Now BPM is going to then take that request message and make a synchronous call to SAP. And when it is doing a synchronous call, the service interface is going to be abstract synchronous, and ECC is going to get the response and give it back to the BPM. Always remember, when all the service interfaces where either the BPM is the sending system or the receiving system are always abstract. Next, once you've gotten the BPM as a sending system, your BPM is going to act as the sending system again and going to push the response back to the file system. And in this case, the service interface is abstract asynchronous. Then what did we go and do? We went into our ESR, and in the ESR, we defined 2 data types, one for the request structure and one for the response structure. So 2 data types and equivalent message types, one for the request and one for the file response. The service interface that we built 5 service interface, 1, 2, 3, 4, 5. The BAPI itself is going to act as its service interface. So SIOA file request is the service interface where the file comes in. It's outbound, asynchronous, and it uses the file request. Next, the BPM is going to receive the file request, and because it receives the file request, it is SIAA file request, and it uses the file request. Next, the BPM is going to make a synchronous call out. So it's going to be SIAS abstract synchronous, and it has the request and the response. You need to make sure it's abstract synchronous. Now the BAPI is giving the response back. So now the BPM is going to send the response out, right? So it's going to be SIAA file response, and the message type is going to be response. And finally, you'll have an SIIA inbound asynchronous file response service interface for the file to get created in PI. Okay, with this, we will now meet you soon where we will be building the ccBPM.